So this is where we left our heroes. We had talked about use of antibiotics for non-bacterial infections and people not finishing the course as causes of antibiotic resistance. But this is another one. I'm going to read it and then I'll shut up while you copy. The use of antibiotics in livestock feed. In the 1950s, scientists discovered that subtherapeutic doses of antibiotics added to feed improved the growth rate of livestock. In the 1970s, studies in the United Kingdom and Japan indicated the risk of antibiotic resistance developing from this practice. And unfortunately, especially in Asia, colistin, an antibiotic of last resort, has been used as a livestock feed additive. In 2015, a colistin resistance gene, MCR1, was found in pigs in China. In 2016, MCR1 was found in a human being in Pennsylvania. That starts to feel a little uncomfortable to those of us here 10 miles from the PA border. And in 2016, the MCR1 gene was also found in pigs in South Carolina and in Illinois. Oh. Okay, so the prefix sub, you know, means under or less than. Therapeutic dose is the dose that's required to treat an illness or an infection. So a subtherapeutic dose is just enough, it's not enough antibiotic to treat an infection. It would be like if I took the big giant horse pill antibiotics that I'm on right now and I cut it up in 10 pieces, and instead of taking the whole thing, I just took a tenth of it. That would be a subtherapeutic dose. It wouldn't be enough to treat the infection in my lungs. It would be a subtherapeutic dose. So the weird part is, and this was sort of an accidental discovery, and I believe it was done in chickens. The weird part is that if you give animals little tiny doses of antibiotic, they actually grow faster. They gain weight faster. And if you're a farmer, your big interest is in, they call it feed conversion. How fast can this steer convert hay to meat, to muscle? How fast can this chicken convert corn to eggs and flesh? It's called feed conversion, and there's a huge science behind it. If you go to Ohio State and you go to the Ag College, there are people working on this every day, improving feed conversion rates in beef cattle, in dairy cattle. It's a huge deal. So in the 50s, it was, first we had these miracle medications that meant people weren't dying of infected teeth and little scratches anymore. And then, oh my God, they really are a miracle, because if we give them to livestock, their feed conversion rates improve. This is huge. Maybe this means we can feed the world on less land. Maybe this means we can feed the world more cheaply. We can lower the cost of meat. This is fantastic. But there's a problem. Anything that seems too good to be true probably is. And this is one of those. So as early as the 1970s, there were scientists who said, you're giving them small amounts of antibiotic. Any bacteria that are weak, that are living in these animals' guts, are going to be killed by these small doses. It's not enough to kill off actual bacteria causing an infection, but it's enough to kill off the weak bacteria. This is a problem. You're going to start to see resistance. Now, things like penicillin. Penicillin is the first antibiotic that was ever synthesized. It was synthesized in the 1940s. World War II. Soldiers used to actually carry little paper envelopes of penicillin powder. And when someone was wounded, a medic would come along and literally dump powdered penicillin in the wound, because in World War I, a lot of soldiers died not of their wounds, but of infections in their wounds. So, this is this miracle antibiotic. Unfortunately, because penicillin is so old, there are very few bacteria that are actually still resistant to penicillin. So part of me thinks, okay, if you're going to give livestock an antibiotic, Give them penicillin. Who cares? It's pretty much like M&Ms at this point, you know. It's ridiculously ineffective as an antibiotic at this point. It's like candy. We could just pass it out. It doesn't matter. Unfortunately, what they were using in China was colistin. Remember colistin? It's the only thing left that would treat the bacteria that were slowly going to kill David and his infected leg. So we've been giving bacteria a peek at our last resort antibiotic. And anytime that we give bacteria exposure to any antibiotic, the ones that are not resistant to that antibiotic get killed, and the ones who survive are the ones that have some level of resistance. So sure enough, colistin resistance genes are now here in this country. The human in Pennsylvania, this was really horrifying because this was a woman in a VA clinic. She was not being treated for an infection. The colistin resistance showed up in, I forget if it was like a fecal culture or a respiratory culture, but it was not a bacteria that was making her sick. She was a carrier, silent carrier. Meaning she had some bacteria in her body that had this gene that were just hanging out while she's spreading them everywhere. And whatever reason she was admitted for, they did fix. The bacteria that was making her sick were not colistin resistant, but there were colistin resistant bacteria that showed up in her body. Terrifying! And sure enough, within the year, there were pigs in Carolina and Illinois. The Carolinas are like hog heaven or hog hell, depending on how you look at it. They've got huge swine feedlots. Has anybody ever seen a huge swine feedlot? Woo! Okay, so in the Carolinas especially, and in Illinois as well, but the Carolinas specifically, you have these massive factory feedlots with hogs. So when you've got 10 hogs or 30 hogs, you can handle manure differently. What happens when you have 1,000 hogs in a confined space? You got a lot of manure. And so to handle that, they build what are called waste lagoons. Who knows what a lagoon is? It's a lake. Well, guess what a waste lagoon is?
A body of...
It's a lake of poop. And they're usually cement bottom. This is a waste management technique, and they bulldoze the poop in and they hose it in, so it's pretty liquidy and it's pretty foul and it kind of ferments. I'm sorry you have me before lunch.
Let's go swimming.
You would not want to swim in this. You would not want to swim in this particular lagoon. There have been several incidents. What just happened to the Carolinas last week?
Hurricane.
Hurricane! We're getting the tail end of it today. This is the tail end of the hurricane coming our way with some rain. The big issue was not the winds. The winds died down pretty well. The big issue was the rain and the flooding. Anybody seeing any problems here? Oh yeah, they overflow the lagoons, and this is an issue in places that use manure lagoons. Is with heavy rain events, sometimes you have leakage. If these things have raised dam walls versus completely submersed, you can have, and there was one that happened, I think in West Virginia a few years ago, or no, it was in the Carolinas, where you had a river down here, and you had the waste lagoon up here, and it was breached, and pretty soon you had a hog manure river. That's a big problem. And these are rivers that people take drinking water from.
Ooh.
These are rivers that people take industrial water from. This is huge. So, it's bad enough. So now your wastewater treatment plant, here's our wastewater treatment plant with the intake for the water and the pipes out to the town. That's really pretty terrible, but okay, we'll take it. Not only does your wastewater treatment plant now have a serious problem in terms of getting the poop out of the water because people can't drink water with poop in it, I mean, they can, but it'll kill them. So not only do you now have a problem with that, the bacteria that were in here. Do you remember how we talked about bacteria exchanging little plasmids, little tiny scraps of DNA? And they said, you know, you could have bacteria in the same puddle, and we looked at conditions in India. Bacteria in the same puddle could trade plasmids. So if you've got MCR1 resistance genes in South Carolina and Illinois, and those hogs are pooping, and their poop's going in the lagoon, when and if that poop escapes the lagoon, what have you just done? You just put, potentially, we don't know, but you've just potentially taken those resistance genes and introduced them to the wider environment. Crap. Yes, literally and figuratively. This is not good. This is not good. Now, this is one of those things that you and I don't have a whole lot of control over. I mean, there are things that I have more control over than you do because I'm an adult, I'm making my own purchasing decisions, things like that. And then there are things that we're both equally pretty powerless to do anything about. This is in that category, you know. There are some laws on the books now. Look at chicken packaging in the grocery store. Because you will see a lot of chicken packaging will say no hormones, no antibiotics. And it's actually been illegal for quite a long time to add hormones to chicken feed. Antibiotics are still added, but it's become sort of a sales pitch. And actually, I'd have to check on the current legislation. It's become sort of a sales pitch that there are no antibiotics in the chicken feed. But it's really common with hog feed. So if you have the option of raising your own hogs or buying your hogs from your neighbor, it's a good option. Because,
so our bacon has antibiotics in it?
Well, the hogs that produced your bacon, the hogs whose, and that's the muscles along the back, most of those hogs were probably given feed that had antibiotics in it. And, you know, here's a great question. I don't know the answer to this. Are there residual levels of antibiotic in the muscle? I don't know. I don't think so. I don't think that those chemicals end up accumulating in muscle tissue, but it's a great question. It would actually be a good question for a lab, for a scientist to run. If you wanted to ask a research question, that's a fantastic one. So I mean, I know that you find a lot of antibiotics in the waste. You find a lot of antibiotic-resistant bacteria then in the waste. You find antibiotic-resistant bacteria very often. Yeah, I don't know. That's a good question. Is there residual antibiotic in the flesh of animals who've been fed antibiotic feed that has antibiotics in it? I don't know. Good question. Let's put that on the list of good questions to ask somebody who knows more than I do. And it's also a good one to see if you can find that answer online. Okay, so we've got this, and this is one we're kind of powerless about. Here's one that we're not so powerless about. So the last one is something you do have a little bit of control over. Not a lot, but a little. And once you're an adult and making all your own purchasing decisions, you have a lot of control over this. Antibacterial soap and other antibacterial products. Antibacterial soaps contain low doses of an antibiotic. Oh. Usually it's triclosan, and we'll talk about that one a little bit later. After antibacterial agents are applied to a surface, your hands, the floor, the counter, they stay there and continue to kill bacteria. Which bacteria do they kill? The weak ones. Who do they leave behind to reproduce? The resistant ones. Antimicrobial chemicals in these products act in a similar way to some of the antibiotics that we use in humans to treat disease. Oh. So if you remember, everything that we've seen says the key to keeping antibiotics effective is to use them as little as possible. So you take an antibiotic, you take your 10-day course, you stop. You take what's needed to kill them, you stop. Do you want to leave antibiotics laying around in the environment to contact more bacteria? No, it's a terrible idea. So the very notion, and this has bothered me for a long time, you can go out and buy an antibacterial cutting board. It's a cutting board, and in the plastic, in the polymer that they use to make the cutting board, they have embedded an antibiotic agent. And it used to always be triclosan. Triclosan was actually banned a couple of years ago from some products, not all products. So it used to be that antibacterial soap always contained triclosan. It doesn't anymore. There are a couple others, tricloban, which is a similar compound, but these are things that just stay in the environment and keep killing off the weak bacteria. Oh boy. What are you to do? Well, just hand washing. Just like serious mechanical hand washing is a great option. For years, I had said, well, okay, there's obviously a difference between alcohol sanitizers and things like triclosan, tricloban. They're antibiotic chemicals. When you get into the annotation stuff, you're going to see that unfortunately some bacteria have started to evolve resistance to alcohol as well as, now where'd it go, to the active ingredient in these buddies, benzoyl chloride. I know, it's so entertaining. Active ingredient. N-alkyl dimethyl benzyl ammonium chloride. Unfortunately, there are now some bacteria that have started to evolve resistance to that. Because guess what? Anything you use to kill bacteria is going to have the same problem. It's going to kill the weak ones. It's not going to kill the resistant ones. So I'm going to introduce, and I did decide, I canned the PSA assignment. I'm going to show you the annotation assignment. We're going to talk about it a little bit. And then tomorrow, you're going to come in and you're going to work on the annotations. We're going to discuss those. Your study guides are due Wednesday when you walk in. So when you walk in for your quiz on Wednesday, vocab with Part C done and study guides go in the box, and you take the quiz, and then guess what you get? A new vocab packet with Parts A and B to do. Because we have these for every unit. Oh, you look like I just kicked you in the shins, some of you. I did? Okay, so let's